This is the ninth Brookings lecture in the lecture series for Brookings Mountain West. And we're pleased to have Adele Morris, who's a Brookings Fellow from Washington. She's also Deputy Director for Climate and Energy Economics. And she's going to have a more detailed introduction by Helen Neal, who's on our faculty, and she is in environmental studies. I want to also note that our next lecture is on March 9th. It's Audrey Singer, who's Brookings Metro Policy Program and a senior fellow there. And her title is The New Geography of Immigrants and Local Policy Responses. With that, I'll give you Helen Neal. Thank you.
Thank you, Rob. It's a real honor and pleasure tonight to introduce Dr. Adele Morris. Dr. Morris joined Brookings in July 2008 from the Joint Economic Committee, JEC, of the U.S. Congress, where she spent a year as senior economist covering energy and climate issues. Her current research focuses on the design of a domestic cap-and-trade program to reduce greenhouse emissions and the economics of potential international climate agreements. She is also an adjunct assistant professor at Georgetown University, where she teaches a graduate course on the economics of climate policy. Before joining the JEC, she served 9 years with the U.S. Treasury Department as its chief natural resource economist, working on climate, energy, agriculture, and radio spectrum issues. On assignment to the U.S. Department of State in 2000, she was the lead U.S. negotiator on land use and forestry issues in the International Climate Change Treaty process. Prior to joining the Treasury, she served as the senior economist for environmental affairs at the President's Council of Economic Advisors during the development of the Kyoto Protocol. Dr. Morris began her career at the Office of Management and Budget, where she conducted regulatory oversight of agriculture and natural resource agencies. She holds a PhD in economics from Princeton University, an MS in mathematics from the University of Utah, and a BA from Rice University. Dr. Adele Morris will be speaking on climate change and real estate, how environmental risks and policies impact markets. Thanks, Helen.
Thank you very much, Helen, and I want to thank Helen for her kind introduction, and I want to start by thanking the folks here at the Brookings Mountain West office, Becky Bolton, Bill Brown, Rob, and the others there in the office. I feel like pretty much everybody at UNLV has majored in hospitality, at least so far as the scholars are concerned. So thank you all very much for your kind welcome. So, whoops, let me see. I don't know how to get that back on. Is there a mouse? Yes, there we go. There we go. So I'm looking at the various linkages between climate change and the built environment and location. So I'm using real estate as shorthand. It seems like real estate seems to get people's attention here in Nevada. But we're going to look at it from a few perspectives. There are going to be a few themes that you're going to hear in this talk. One of the themes is that change is inevitable. Either we're going to have change from a changing climate, or we're going to have change that results from policies to avert a changing climate. But the differences could be profound when and where and who experiences those changes. One of the final themes will be an emphasis on the potential for adaptation, either for a changing climate or a changing economic environment. So there's three primary linkages between climate change and property values. And these tend to be the three categories of effects that the Intergovernmental Panel on Climate Change study. But I'm going to take a very U.S. focused look at this. Impacts are what we talk about when we're talking about the effect of changing climate on property values, local economies. Adaptation, of course, is the response to those changes. And mitigation is the efforts you need to undertake to reduce emissions, and those have their own economic effects. So there are a few ways to slice. So I'm going to start with impacts. And there's a few ways to slice it. You can think of, well, what are the impacts we've seen already? And what are the impacts that are projected? Certainly, projected impacts are much larger than what we've observed so far. And when you look at projected impacts, you have to be clear about what scenario you're projecting. There are emission scenarios that are relatively flat, and we manage to stabilize greenhouse gas concentrations at a relatively modest level. And there are emission scenarios where those emissions keep on going up and up. And the projected impacts from the changing climate vary significantly according to the emission scenario that you're positing when you're making those projections. In addition to the emission scenario, you need a relationship between greenhouse gas concentrations and how the climate responds to them. And those tend to be buried in the climatic models that scientists use to make these projections. And you'll see some results from those models later on in the talk. And the other way to slice climate change impacts is by location, sort of the spatial extent that you're looking at. There are global impacts. You can think of national impacts, regional impacts, local impacts. But the smaller scale you get in looking at those potential impacts, the more uncertainty there is in what those impacts might be. So I'm going to try to focus at the national and regional level, but I'll give you a couple slides on potential global effects. Again, though, you're slicing those spatial relationships given a particular emission scenario. So the scenarios that you'll see in the talk that I'm going to give are taken from emission scenarios developed by the Intergovernmental Panel on Climate Change and used in a national assessment of climate impacts that the U.S. federal government has produced. And these are the two scenarios. One is a low emission scenario. And of course, what matters is global greenhouse gas emissions. This is just carbon emissions, but in addition to this, you'd have to have a scenario for the non-CO2 greenhouse gases. And you can see that the high emission scenario keeps on going up, and the low emission scenario tapers off. So the global emissions peaks mid-century, tapers off, and this corresponds to roughly a stabilization of the climate at about 550 parts per million volume. Okay, so you'll see different sets of results for those two scenarios. Now, I apologize for the resolution of this slide. I couldn't find one that had better resolution, and I thought it was an interesting slide. So this is showing the greenhouse gas concentrations before there were emissions. So that's units of emission per year. And this is total concentrations in the atmosphere. And this is the prehistoric record as derived from like little air bubbles in ice cores and that sort of thing. And so this goes back 800,000 years. Right now we're at this blue dot. And in the low emission scenario, by the end of this century, we'd be at the green dot. And in the high emission scenario I just showed you, we would be at the yellow dot. So you're going to be comparing projected outcomes at the green dot and the yellow dot. But you can see that the blue dot is already elevated relative to that record that goes back 800,000 years. So I'm going to start with global effects. And I showed slides like this last time, but MIT has actually updated its Wheel of Fortune, so I wanted to show it again. This is the global mean temperatures for something that's roughly like the high emission scenario I just showed you, only it's MIT reference scenario. This is if we don't have any policies to constrain greenhouse gases, and by 2100 we would be spinning this particular roulette wheel, and the probabilities would be such that we could land on any one of these wedges, and the bigger the wedge, the higher the probability of landing on it. And so again, no policy scenario, these are the chances that we're taking. And then if we were able to stabilize at the 550 parts per million, which corresponds more to that low emission scenario I just showed you, we would be essentially purchasing a new wheel, and it would look more like this one. And this is according to the modeling done by MIT. So that's kind of a global picture of the difference in the sort of probability distribution around changes in global mean temperature. And now I'm going to start looking at national and regional issues. So where am I getting all this? The federal government has a organization, kind of an interagency process called the Global Change Research Program. And they have a consortium of federal agencies that get together, and every few years they produce a synthesis and assessment of climate science with a focus on the United States and potential climatic impacts in the United States. And this came out last summer. Now, I think there's an effort to try to make it a bipartisan or a nonpartisan document. Most of the work that was done for this report was done in the Bush administration, but it was issued during the first 6 months or so of the Obama administration. And I'll be showing a number of graphs and charts from this report. And if you're really interested in this topic, I highly recommend it. And furthermore, you can look through there at the citations and delve into specific topics to your heart's content. The climate change changes that it projects depend on the two emission scenarios that I just showed you. And particularly for the high emission scenario, there are projections for all sorts of changes. And some of them are not necessarily bad changes, but changes nonetheless relative to what we've experienced historically. A lot of it has to do with extreme weather events, changes in the hydrological cycle, temperature, and the timing of different seasonal changes such as snow melt and the arrival of spring and migrations and stuff like that. Now, to give you just a feeling for what kinds of effects the report talks about nationally, the first chart on the left is changes experienced up till today relative to 1961 to 1979 as sort of a baseline for temperature, and comparing that to average temperatures from 1993 to 2008. And so, in general, the United States has gotten a little bit hotter in those few decades since the 1960s. Now, their projections in the next 20 to 30 years are for that to continue. You can see the effects are national, but if you look up at the Alaskan map, you can see that they're more pronounced at those higher latitudes, and in particular the northern tip of Alaska could be potentially profound even within the next couple decades, according to these projections. There we go. So like I said, not necessarily all of these changes are bad. I mean, some of them might make certain areas more hospitable for human societies than they were before. But there are certainly ecosystem changes that you might care about, whether it's the polar bear and whether it will survive in its native habitat and that sort of thing. But in terms of the built environment and property values, we can adapt, and I'll show you some graphs that illustrate our ability to adapt to different climates. But the challenge, of course, is going to be the rate of change in the climate and how well the new climate, or how well the built infrastructure is suited to the new climate. And just for example, in the last few weeks, we've just had the snowiest winter on record in the Washington, D.C. area. And we've just had, like 3 feet of snow in the space of just a couple weeks. And, there was so much snow, it just ripped the gutters off the back of my house, and a tree fell on my house, and the lanes of traffic were blocked because there was so much snow. They didn't have anywhere to put it, really. But if you think about a city like Buffalo, they have that all the time. So their houses are built a certain way, their vegetation is a certain way, and they have ways of handling all that snow, so it's not such a big deal. So really it's about your ability to adapt to the new climate and how fast you're going to need to do that. So the regional predictions, I wanted to focus on the Southwest, and I'm again taking this from the report that I just showed you. But clearly one of the most robust results from this synthesis seems to be around water and the increasing scarcity of water as a result of a potentially changing climate. But certain other factors like the temperature itself certainly will be an issue. And here's a chart that shows the projected temperature increases in the Southwest under the 2 emissions scenario I showed you. So you can see some little yellow rectangles and some orange rectangles, and those are the sort of confidence intervals of the projected mean temperature increases in the Southwest. And you can see that by 2090, mean temperatures in the Southwest are predicted to be very significantly higher than they are now, and in particular in the higher emissions scenario. That translates into all sorts of needs to adapt in terms of cooling degree days and that sort of thing. And I wasn't able to find projections specifically for Las Vegas, but in terms of heating degree days and cooling degree days, here's a chart that shows you projections for 4 major cities in the United States. And again, I apologize for the resolution of this this figure. Let me see if I can use my laser pointer here. So here's my little pointy hand. Now here's New York, and you can see the light blue is cooling degree days in the reference scenario, and the light yellow there is heating degrees days in the reference scenario. I mean in the historical levels of heating degree days and cooling degree days. So in the lower emission scenario, you have to do more cooling, but you have to do less heating. And that's true across the board. Okay. Now, probably Los Angeles is maybe the closest in climate to Las Vegas. That's hard to say, but Los Angeles is predicted in the high emission scenario, which is the purple, to have a really significantly increased cooling degree days. Now, that level of Los Angeles, a little bit over 3,000 degree days for cooling, is where Las Vegas already is. So you can imagine that if Las Vegas shows a pattern similar to Los Angeles, it would be way up there in the high emission scenario. Again, assuming the high emission scenario. So this is perhaps more disturbing to me in terms of the potential for conflict and sort of social disruption. I mean, you can put an air conditioner, you just have to generate the electricity and so on. But This is a lot harder to do something about. These are the projected precipitation changes relative to historic levels. The left is the low emission scenario and the right is the higher emission scenario. And the darker the brown, of course, the lower the greater the reduction in precipitation projected. Now again, this is out to 2080, so this is pretty far out there. But you can see that Las Vegas lies right in here at some of the sort of the epicenter of the projected precipitation declines, even in the lower emission scenario. So even if we're able to reach about 550 parts per million, you're still mapping that down to a 25% decrease in precipitation relative to the 1961 to 1979 baseline. And then in the higher emission scenario, then you're not only in the epicenter, but you're surrounded by even more folks with the exact same problem. Okay. And this is another set of data that shows somewhat the same thing. This is projected change in runoff, only it's a nearer term result in the sort of mid-century time frame. This is based on emission scenario somewhat between the low and high that I showed you, but you can still see that even by mid-century, the projection is to have a significant drop in these available waters. Okay, so this is again a cut and paste where I couldn't get the data to make the resolution good, but you can just see that already we've had demographic trends that have driven people to exactly the places where the projected stressors on water are likely to be some of the worst. Okay, so this is population change since 1970, and there we are, right here. And so people are, in general, coming out of the Great Plains midsection of the country and into these areas that were some of the most stressed by water already. And so if that didn't get your attention, this probably would. So folks who do demographic projections of where population is like to change in the future, 1/3 of all U.S. projected population growth is projected to take place in just the Mountain West, and that's a 65% increase from 2000 to 2030. So the trends I just showed you are not expected to taper off, but rather to continue. And so you can kind of figure out yourself what that likely means as far as potential squabbles over water. But over the long run, cities are going to adapt, so things will change. People will figure out where to get water. It might mean some disruptive social changes in some areas. It might mean that we have to change patterns of agriculture, for example. It might mean prices for water may change. But in the long run, most cities will adapt because we've got maybe 70 years before some of the projected results I showed you. But one thing to keep in mind is, so yeah, there's this disruption, but what do we know about economic activity and climate? And it's worth looking at a chart like this, which is per capita income in the United States. This is in 2002. But the point being that you don't see systematic relationships between, say, latitude and per capita income. You see maybe relationships between rural and urban and per capita income. But there are well-off cities in the south and well-off areas in the south and in the north and the west and the middle and even in Alaska. So if you were to just say, well, the climate's getting warmer on average, you can't necessarily conclude anything about what that's likely to do to economic activity without a lot more analysis, because people can live all sorts of places and adjust to that. So I think the United States, particularly over long periods of time, cities will adapt, like I say, but you want to be mindful of the poorest in those cities, the people who aren't going to be able to afford the air conditioning as easily, who are going to be vulnerable to increased costs that way. And certainly this is a very US-centric view. If you take these same kinds of phenomena and put them in other poor countries, countries where agriculture is a much larger share of the economy, for example, particularly rain-fed agriculture, you can get very different social impacts from these climatic changes. And even if we are able to adapt and you know, our people are mobile between areas and they move away from less hospitable to more hospitable areas, there are still the potentials for very catastrophic results that would even overwhelm a rich country's ability to adapt. And I haven't even begun to talk to ecosystems and the ability for ecosystems to respond favorably to all these changes is quite a question, and I know there's good work being done here at UNLV on some of these questions. So now I'm going to move away from the discussion of climatic change and those impacts to, okay, now let's say we have a mitigation policy and we're going to try to achieve our lower emissions scenario. What does it entail? And that's not an easy thing either, right? So now the time scale of doing that work is very different. So the impacts I showed you were mid-century, later in this century. If we're going to have a policy to control greenhouse gases, that's going to ramp up, you know, as soon as we get it passed. Now, the early years of the effects of that policy, the economic effects might be pretty modest, but you'll see that over time they're going to go up as well. So I'm going to focus on economic analysis of cap and trade because that's one of the main policy proposals that's been through Congress. There's a bill that's gotten through the House called Waxman-Markey, H.R. 2454, and some of the results you'll see are from analyses of that bill. So the basic idea is you cap emissions, you set a right to emit a certain amount, but they're capped. The number of those rights are capped, and you allow and you devolve those rights out to a regulated population of firms, and you ensure that if you're going to emit, you have to have one of these rights. But you can buy and sell these emissions allowances, and that creates a market for those rights that puts a price on carbon and other controlled greenhouse gases. So what you're going to see is economic analyses that say, okay, now we're putting a price on carbon. It's going to change the prices of different kind of energy depending on the carbon content of different kinds of energy, and then how the market responds to those new relative prices of fuels. So this is the bill I was telling you about. It's very big, it's quite complicated, but I'm mostly going to be focusing on Title III, which is the cap and trade. Now, over the long run, this is quite a reduced emissions scenario for the United States. It would be an 83% reduction in U.S. emissions relative to 2005 levels by 2050. So it would be fairly ambitious for the United States, particularly over the time frame to 2050. Now, for the scenarios I showed you before, I had to do global emissions because that's what determines the climate impact. Now we're just looking at U.S. mitigation policy. Of course, I'm not trying to say that if the U.S. reduced by this much, that the global impact of that would be what I was describing earlier, because it depends on what other countries do. So the main thing to gather, these are results from the U.S. Environmental Protection Agency and their analysis of the bill. And these different colored bars are different ways that policy could play out. in terms of things like the availability of nuclear power or the availability of carbon capture and storage for coal plants, or the availability of offset credits from projects that are undertaken outside the capped sectors. The main thing to take from this graph is that there is a projected impact on electricity prices. These are national averages for households, for gasoline, and for natural gas. The light blue bars are the reference scenario. So electricity is projected to go up even without this policy, but the policy will make them go up faster than they otherwise would. And that just stands to reason because you're transitioning to more expensive, coal is essentially burnable dirt. If you're going to move off of that, you're likely going to have something that's more expensive. And gasoline as well. Now, in some of the scenarios, energy prices could go up by a lot more. And those are generally the scenarios where you don't have available new nuclear, or you don't have carbon capture and storage for coal-fired electricity plants. And now prices are one thing, but to get expenditures, you need prices times quantities. And these are charts about household energy expenditures also going up, but perhaps not as fast as prices. And the reason for that is the bill includes some energy efficiency measures. So if you consume less energy, even if the price is higher, you can moderate your overall energy bills. And you can see that these policies would definitely have an effect on household budgets on energy. And here's a little snapshot. Now this is looking at a different set of results for the same bill, this by the Department of Energy's Energy Information Administration. And this is just electricity. But you can see also they have the same general pattern of prices going up as a result of the bill over time. This goes to 2030. And the highest price scenarios are the case where, in this case, there's no international offset credits, and the technologies for electricity are limited, in particular nuclear and carbon capture and storage. So that's kind of a bad case where not only you can't reduce domestically as easily because you don't have those technologies, but you can't reduce abroad as well. So that's kind of the national picture of what climate policy might do to energy prices. Now let's kind of delve into regional effects. But before I do that, I just want to make a comment about, well, what are all these energy prices going to do to property values? It's going to change the relative costs of different activities in the economy. So as gasoline prices go up, all else equal, properties further from the city center are going to become less valuable. I mean, we already saw that in the gasoline spike the price spike we had, the oil price spike, what was it, about a year and a half ago? And we saw that really contributed, at least in the DC area, to the sharper decline in housing values further out away from the city center. It changed the relative value of different vehicles people might buy. It changed the car market a little bit, at least temporarily. And the energy price increases are also going to have an effect on the relative value of different properties from an energy efficiency standpoint. If you've got a house that's been retrofitted to be more energy efficient, all else equal, that's going to be a little more attractive when prices are higher. Now, looking at the regional effects of cap and trade, this has been an area of some concern because there's been this worry that because some areas burn much more coal than other areas, that this would have a disproportionate negative effect in certain regions. I'm still looking at this data, but I'm not sure you can conclude from the analysis that there are these very disproportionate regional effects of the climate bill. I'm going to show you some results of carbon footprint of different metropolitan areas, but going from the carbon footprint of different cities to the economic impact on communities is not exactly straightforward, particularly when you scale it by income of those same regions. And I'll show you those results. Okay, so this is from a study that was done at Brookings. This is the group of researchers down here called Shrinking the Carbon Footprint of Metropolitan America. And this is looking at where the greatest transportation-based carbon emissions are across the country. And you can see in areas with lots of driving, you have the areas where emissions per capita are in the highest quintile, and then areas where there are less driving and very relatively dense population, you see lower transportation carbon emissions. So that's transportation. And this is residential energy use. And there are some similarities, but there are some differences. So for example, in California, you see where you saw that transportation emissions, you see a lot less residential energy use per capita. Now, some of the areas where they're both relatively high are in parts of the midsection of the country. See, there's the Ohio Valley. There we go. So some of those are both relatively high in transportation and in residential energy use. But then other areas, they offset one another. And so, right. So this is a slide that shows southern and midwestern metro areas have relatively higher transportation. No, this is the sum of transportation and residential energy use. These areas are relatively higher than the west and northeast. Now that's carbon emissions per capita, and it's looking just at transportation and residential energy use. So it's not counting commercial and industrial carbon emissions or other greenhouse gas emissions. Now this is looking at something else. This is looking at, it posits a carbon tax, in this case $20.91 per ton of carbon dioxide. And it says if you put that carbon tax on based on the production or the consumption patterns of goods and services and energy in 2006, what would be the cap and trade program's average cost per household? Okay, but this is as a share of income. It's not just per capita. Okay, so it's scaling for the local income. So it's a measure of sort of your ability to pay these costs in a way. And you can see that even though up here the West had relatively lower per capita emissions, they're still in the higher group of as a share of income effects of the climate policy. So I think there's still some explanation that remains to be understood between the nexus between the carbon footprint. Some of it is the scaling by income. Some of it is indirect consumption of energy based on other goods and services. So like whenever you have, you buy airplane tickets, well, it's not residential energy use and it's not transportation of gasoline, but it's a good, a lot of which is the price of which is based on fuel. So so there are a lot of indirect energy consumption that affects household impacts as a share of income. So that could be some of it. But anyway, but one thing to note is, yeah, there are differences, but they're actually not all that big, and they're a lot smaller than the differences in the carbon footprint. So the concern by some policymakers that their area is going to be relatively hit much harder than some other area does not seem to be borne out by the evidence, at least as far as some of these these studies, and there's now coming another tranche of regional analyses that should help us understand that even better. So the conclusions of this talk is that climate change could make existing problems worse. We saw that with the drought or the precipitation figures. And we may see increasing energy bills either because the climate's getting hotter or because we're doing something to avoid a hotter climate. But the time frame in which those costs might be going up are different depending on what's causing it. Water stands out, and when I came to this question, I was agnostic. I mean, I'd heard a lot about water here out west, but it certainly stands out as the key issue for potential climate impacts out west. And so to hedge your bets, as any good resident of Las Vegas would do in a case like this to limit your downside risk, certainly improving energy efficiency and water efficiency seems like a good thing to do. Thank you very much. I look forward to your questions.